Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 8 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 808, soup servings. Let's read the problem statement. You have two soups A and B, each starting with n ml. Okay, each starting with n ml. Okay, n here and n here. All right. On every turn, one of the following four serving operations is chosen at random, each with probability 0.25, independent of all the previous turns. Okay, so total four operations are there, right? Okay, and for all these operations the probability is 0.25. Okay, so for all these probability is 0.25. Okay, okay, or I can say four operations, like let's say A operation, B operation, then C operation, then D operation. Okay, right, divided by 4. Okay, or one, I can say divide by 4 as 1 by 4. All right, or I can say it as 0.25. Okay, so simply if I just multiply it with 0.25. Okay, so because probability is 1/4. Okay, 0.25, right? Okay, so what are those operations? Pour 100 ml from type A and 0 ml from type B. Okay, then 75 ml from type A and 25 ml from type B. Then here 50 ml from type A and 50 ml from type B, or 25 ml from type A and 75 ml from type B. Okay, if you notice one more thing here, 100 ml, 75 ml, okay, 50 ml, 25 ml, or 0 ml, 25 ml, 50 ml, 75 ml. Okay, all these serving amounts is a multiple of 25 ml. Okay, right? So if I divide this 100 ml with the 25 ml, okay, I will get 4. Let's say 4 units. I can say 4 units of 25 ml. That is nothing but 100 ml. Okay, 1 unit is equal to let's say 25 ml, right? Here if you notice 100, 75, 50, 25. Okay, all this serving amount is a multiple of 25, right? So here I can say this, if 1 unit is 25 ml, then 4 units is equal to 100, right? 3 units is equal to 75 ml, 2 units is equal to 50 ml, 1 unit is equal to 75 ml. Here 3 units, here 2 units, here 1 unit, and here 0 unit. Okay, I just change it to units. Okay, here also same, starting with n ml. So I can say that this is nothing but uh, if my n value is 50, then I can say total 2 units. Okay, a value is 2. Okay, b value is 2. Okay, since you have two soups A and B starting with each n ml. Okay, 50 ml, I can say 2 units. Okay, 1 unit is 25 ml, so here B is also 2 units. Okay, this is for 50, right? But if instead of 50 here we have 55, okay, as the n value, right? N can be 0 to 10 to the power 9. Okay, here in these operations everyone is multiple of 25, but here if my n value is 55, then what is the value that I'm going to get here? If I divide it with 25, so 25 to 50, and here still some units are left out. Okay, so it is saying that 2 units, I can say 2 units, right? 2 units plus 5 ml more. Okay, so this one also we can put in some other cup, right? This remaining portion. Okay, so then also we need to serve one more time. Okay, in order to empty this 5 ml, right? So what I'm going to do, I'm going to take the seal value of this one. Okay, so here if I'm getting 2 point let's say 50, here 2.2. okay, so I will just say that this is nothing but 3. Okay, I will just say 3 units are there. Okay, so in 2 units I have complete 25 ml, 25 ml, and in 1 unit I have just 5 ml, so I will say total 3 we have. Okay, so you have to just find out the serial amount. Okay, okay, so here uh, you can use math.seal. Okay, math.seal. So if you write 550 or 55, let's say, and divide it with 25. Okay, and just do the math.seal here. Okay, math.seal. So let me show you here now. So in this example, let's say if n value, okay, int n is equal to, just you have to change it to int, but let's not change it to int. Okay, so here first if I write math dot seal, okay, and here n divided with 25.0. okay, so here if I'm just going to return n from here, right, so let's see what is going to happen. Okay, so here variable n is already defined. Okay, let's use some other variable now. N is already there. Okay, so let's say here you say m. Okay, here let's say return m, and here let's use double. Okay, because we are going to get some double value, right? So here let's use double. See, our return type is double, so that is why I'm using double here. Okay, so here you are getting what, 2. Okay, here 100 400 you are getting 4. Okay, good. But here if I write 55, let's say, and if I run it again, so I'm going to get 3. Okay, so see here for 55 I'm getting 3. Okay, so this is one way to do this. Okay, this is one way so to do this. Or there is one more way if you want to do this. If you write a double g, let's say this variable g. Okay, so here if instead of this, if you write whatever the n value you have, in that add 24. Okay, add 24 and then divide it with 25. Okay, so if you return g now, all right, so let's see. So see, now also you are going to get 3. Okay, so you are returning g. All right, so you are getting here, see, 3 only, here 4. Okay, if I write 25 now, so I will get let's say 100 plus 25, 125. 125 divided by 25, I will get 5. Okay, we don't need 5. Okay, so here I'm just incrementing it until 24. All right, so these are the two ways. Okay, you can choose the first way, this way to do this, or you can choose this way to do this. Okay, it's your choice, right? Okay, this is clear. All right, so here note that there is no operation that pours 0 ml from A. Okay, so here you see 4 3 2 1. Okay, 0 ml from A and 100 ml from B. All right, so this is one point. The amounts from A and B are poured simultaneously during the turn, and if any operation asks you to pour more than you have left of a soup, pour all the that remains of that soup. Okay, all that. Okay, so if here I'm left with 5 only, but if it asks to pour 25, then I have to just add this now completely. Okay, the process stops immediately after any turn in which one of the soups is used up. Okay, so if any soup is completely used up, I am going to stop it. Okay, we have to return the probability that A is used up before B. Okay, A is used up before B plus half the probability that both soups are used up in the same turn. Okay, answers within 10 to the power minus 5 of the actual answer will be accepted. Okay, 10 to the power 5 minus 5 of the actual answer will be accepted. Okay, so total probability I'm going to get is 1. Okay, max. Okay, total probability that I'm going to get is 1 max value. Okay, so it is saying answer within 10 minus 5. Okay, so if I subtract 10 to the power minus 5 from it, what is the result that I'm going to get? 1 minus 10 to the power minus 5. I can write it like this: 1 1 2 3 4 5. Okay, I can write it like this here if I solve it further now, 1 2 3 4 5 minus 1, and here 1 1 2 3 4 5. I can write it like this. From this subtract 1, so you are going to get something like this: 9 9 9 9. Okay, 9 9 9 9, here 9. Okay, to total I think 1 2 3 4 5 nines you will get, right? 5 nines you will get. Okay, so once this is done, all right, I hope that I'm not doing any mistake. Okay, 1 2 3 4 5. Okay, 1 2 3 4 5. Okay, if you subtract 1 from it, so here 10 minus 1 9. Okay, here also 9, here also 9, here also 9, here also 9. So 1 2 3 4 5. Yeah, right, 5 I'm writing, right? Okay, so if you divide it with 1 1 2 3 4 5, so what is the result that you're going to get? 1 2 3 4 5. So you are going to get something like 0.99999. Okay, something like this. So when your probability is around this now, just simply say that it is 1. Okay, if you say it 1 now, then also it is accepted, right? If you just say it 1, right? Because it is saying that answers within this 10 minus 5. Okay, so from 1 if I subtract this now, so as soon as I get a reach here now, if for any probability, okay, if for any n value that I'm passing for both a and b, if I get result closer to this one now, or something like this 0.999, okay, closer to 1.0, I can simply say 1.0. okay, because answer within this range will be accepted. Okay, so this is clear. All right, so here if you see now example number 1, what we have n is equal to 50. Okay, so here just take this, uh, these are the values, right? These are the values that we have, and now n is equal to 50. Okay, I can say that 2 servings, okay, 2 units, right? 2 units, because one unit is equal to 25 ml. All right, so now here what is going to happen? We have 2 units, right? So here initially b and a and b, let's say. Okay, a and b, so here a value is also 2, b value is also 2. Okay, right? Now here these four are the things, right? These four are the operations. Okay, so here let's say operation 1 happens, operation 2 happens. Okay, if operation 3 happens, or if operation 4 happens. Okay, so if operation 1 happens, then here if you notice a is 2. Okay, from 2 if I'm subtracting 4, okay, it is saying 400 ml from type A. Okay, 100 ml, so 2 minus 4, 2 minus 4. Okay, and 0 ml from b. Okay, so here I can say 2 minus 0, right? Same way here it is saying 3 units. Okay, so I can say 2 units are there in total, from there 3 units. Okay, and 25 ml. Okay, 1 unit from b. Okay, so I can say 2 minus 1. Here 2 units from type A. Okay, so I can say 2 minus 2. All right, and here 50 ml from type B. Okay, 2 minus 2. Okay, and here it is saying that 25 ml from type A. Okay, 1 unit, so 2 minus 1. And here it is saying 75 ml from type B, 75 ml, so 2 minus 3. Okay, right? So here in the problem statement is saying that return the property that A is used up before B. Okay, A is used up before B. So I am saying return the probability that A is used up before B. Okay, so I can say that if my A becomes less than equal to 0, that simply means units. Okay, number of units. Okay, so here I'm subtracting the A value. So if A becomes less than equal to 0, okay, if it is used up before B, okay, then in that case simply return 1.0. Okay, A empty first. A empty first. All right, and now it is saying here plus return the probability that A is used up before B, plus half the probability we have to return that both the soups are used up in the same turn. Okay, both the soups are used up in same turn. Okay, so here let's say A becomes less than equal to 0, and okay, your B also becomes less than equal to 0. Okay, so in that case what you need to return, you need to return 0.5. Okay, both empty at same time, both empty at same time. Okay, this is what you need to return. All right, and here if your b empty first, okay, b is less than equal to 0, so you have to simply return 0.0. Okay, if b empty first. So I will just use now the if condition, if, else, if, and here else, if. Okay, something like this, right? Okay, so here this is what we need to do. Okay, so if a used up, right, a is used up before, that's the probability we need to return. Okay, and if plus half the probability that both the soaps are used up in the same time. Okay, so here if you see this p minus 2, okay, p minus 2 and here 2. Okay, so a becomes less than equal to 0 now, so here return 1.0. okay, from here we are returning 1.0 back. Okay, 1.0. Here also, here p minus 1 and here 1. Okay, so here also a used up before, so from here also I am returning 1.0. okay, here from here also I am returning 1.0. now here see, both the soups are used up. Okay, both become 0, a is less than equal to 0 and b is less than equal to 0. So in that case I'm going to return 0.5 from here. Okay, now see in this case p is 1 and here this is minus 1. Okay, b is used up, so in that case simply return 0. All right, so this is what we are returning, right? 1 here, 0.5 here and 0 here. Okay, so here if you see 1 1, okay, then 0.5, okay, 1 1 0.5 and from here 0. Where is this 0? Okay, this is what we are getting, and here we have to just multiply it with 0.25. okay, for everything possibility is 1/4, right? Here if you see a plus b c d, okay, and chances of everything is 0.25. okay, so divide by 4 or multiply with 0.25. okay, so this is what we are doing here, right? So what is the output that you are going to get? You are going to get 0.625. okay, so here this is the explanation. Okay, so if we perform either of the first two serving operations, soup a will become empty first. Okay, so here I proved now soup a becoming empty first here, right? And if we perform the third operation, a and b will become empty at the same time. If we perform the fourth operation, b will become the empty first. Okay, so the total probability of a becoming empty first plus half the probability that a and b becomes empty at the same time is 0.25 into this. Okay, so you are going to get this as your output. Okay, same way for this example, n is equal to 100, so output is this. If we perform the first serving operation, soup a will become empty first. Okay, so this you can try. Okay, so here 4 units in total, right? If we perform the second operation, a will become empty on performing the operation 1 2 3, and both a and b will become empty on the performing the operation 4. Okay, so if we perform the third operation, a will become empty on performing the operation 1 2. Okay, so and both a and b become empty on performing the operation 3. Alright, so if we perform the fourth operation, a will become empty on performing operation 1 and both a and b will become empty on performing the operation 2. Okay, so the total probability of a becoming empty first plus half the probability of that a and become empty at the same time is this. Okay, so just try to solve it like this. Okay, so here you are going to get some value. Okay, so now if here we are just returning, right, because here we are meeting this condition, if condition. Okay, so if these conditions are still not met now, then also from this step also there are 4 choices. Okay, from this step also there are four choices. Okay, like this. So try to solve it. Okay, all right, so this is our constant. Okay, so now how we are going to solve this problem, let's see that. Okay, so here if I get to know, okay, if I get to know when I'm going to get this value for very first time, okay, for which n value, okay, I am going to start getting the values like this 0.99 or okay, or something closer to 1.0. in that case I can simply return 1, right? But initially I don't know this, right? I don't know this number. Okay, so initially I'm going to just write very few things in the code. Okay, let's see. So here this is the requirement, right? So let's say let's change it to int. Okay, because we are not going to return this m value, but here we need this as int. Okay, int, you can use this. Okay, so we are not returning this. Okay, so I'm just creating this variable. Okay, Now here first we have to convert the millimeters to units of 25 ml, right? Because every serving amount is a multiplier of 25 ml. Okay, so for this we are doing this int m is equal to int this. Okay, now here we are going to also create one memoization table. Okay, but first let's do one thing. Okay, let's write one loop. Okay, so here int k is equal to 1 I'm starting, let's say. Okay, so here we have 2 units. Okay, 2 units, f50 means 2 units. Okay, a is 2 b2. Okay, here n is equal to 100 means 4 units. Okay, so first we have 1 1, then next time we have 2 2, next we have 3 3, next we have 4 4, next we have 5 5. Okay, and something like this. Okay, so here in this case we have 4 4. Okay, this case, in this case 50, that simply means 2 2. Okay, so this is how we are serving now starting. Okay, so here for bigger values maybe you get 4800, 4800 in the starting. Okay, maybe you get 500. Okay, 500. So here if you are starting with here now, you are seeing the answer like this 0.6250. Okay, and here n is equal to 100, you are getting this. Okay, so definitely with the increase in the value of n is equal to 100, you will see that your output is also going to be increased. Okay, the probability is also going to be increased. All right, the output, right? So definitely for the bigger values only, okay, some bigger values only, my result will be close enough to 1.0. Okay, so for bigger values I can simply return 1.0, right? But now question is, how do I know this value, right? If that value is starting from 4800, okay, how do I know this value? Okay, so we don't know, right, initially, right? So let's calculate first what is the output that we are going to get for 1 1, what is the output that we are going to get for 2 2, what is the output we are going to get for 3 3, what is the output we are going to get for 5 4 4. Okay, so as soon as for any of this output, okay, if we are started getting the results closer to 1.0, then for all these bigger n values I'm simply going to return 1.0 only. Okay, so here k is equal to 1, starting with 1, k is less than equal to m. Okay, k is less than equal to m. Okay, number of units, right? And here k plus plus, k plus plus. All right, and here inside this I'm just going to calculate. Okay, let's say calculate dp. Okay, so in this calculate dp method, okay, I'm passing k for a, k for a, k for b, and I'm just going to pass this dp. Okay, done. All right, so this dp I will show. Okay, if this value becomes greater than 1 minus 1 e, okay, minus 5. Okay, that is nothing but 10 to the power minus 5. Okay, so this is nothing but, I have already proved here, 1 minus 10 to the power minus 5. Okay, this is what I'm writing. So this is nothing but 0.999. Okay, something values if my value comes closer to this. Okay, bigger than this. So in that case, okay, for I can say for any larger m, probability will be even closer to 1. Okay, so in that case I'm just going to return 1.0 in my output. Okay, so if we are not returning this 1.0, okay, then that simply means here I can say if cutoff not reached, okay, then just simply compute the actual probability for m comma m. Okay, m comma m. Okay, whatever the m units. Okay, then we can easily calculate. So here in that case what I have to return, I have to return this same. Okay, this same method, but here instead of k I'm just going to pass mm. Okay, so initially we are starting from mm now. So here I just make sure that with this mm, maybe if I get 1.0, okay, right, so I will stop, right? So here if I don't write this now, for very bigger values of this m, okay, for very bigger values of this m, I will get the memory limit exceed error. Okay, right? So here I'm starting from 1 1 itself, okay, then 2 2. I will check all the numbers, okay. So maybe let's say for very big number, okay, 6 8 7 9 8, okay, I will get a memory limit exceed error, okay. But for this one, output is going to be 1.0, okay, 1.0, let's say, because n can be from 10 to 9, okay. So this is very big number, but if I write this, okay, and with this code if I write, so I will get memory limit exceed error, okay, right? So what I'm going to do, as soon as I'm going to run one loop here itself in the starting, okay, 1 1 2 2, okay. So if for any number, if I started getting the probability is closer to 1.0, for all the biggest number also probability is going to 1.0, okay. So I will exit completely here only, okay. If for any smaller number I get 1.0, for bigger number itself is also going to be 1.0 only, okay. And I will show you that probabilities are going to be increased, okay, when I'm going to run this code, okay. This is done. So here what is this DP? So DP is nothing but uh, we have servings like this, okay, A and B in the starting, and there is some result for this, okay. Then here we are doing some operations, huh? Like A is decremented by 4, okay, B is decremented by 0, okay, and then for this one there is going to be some result, okay. Then here we are decrementing, let's say A by 3, and B by 1, okay. For this one there is going to be some result, okay. So this is how we are calculating, okay. For this one also 4 parts, okay. So we are only stopping if these conditions are met, okay, if these conditions are met, right? But otherwise we are just proceeding further, okay. So if I have already stored the, if I have already solved this tree, let's say, okay, and somewhere later also in my code I'm passing the same values, okay, then I can simply get the result from here now, right? So for this purpose I'm storing the result here in some hash map, okay. So here what I'm going to do, I'm creating one memoization table, okay. So let's say memoization, okay, memoization table, all right. So here dp A and here B, okay. So stored dp A and B, okay. This result is stored as a nested hash map, okay. So if my A value is 25, okay, and my B value is 50, then what was the result, okay. If my A value is 25 and B value is, let's say, 70, then what was the result, okay. If my A value is 25 and B value is 60, then what is the result, okay. If my A value is 50, my this value is 25, then what is the result, okay. This value is 50, what is the result, okay. So if I have already solved this part now, and later on in the in some other tree, if I'm fetching the same details, I can simply return the result and I don't need to calculate it again and again, okay. So that is the use of this. So here dp A and B here, okay. dpab is the probability result starting with a units of soup A and B units of soup B, okay. A units of soup A and B units of soup B, all right. So here how we are going to create this, so I'm going to create it like this map and key as, let's say, A value, okay. And here inside this nested hash map, okay. So here also I am passing the key for B, integer, and the result, okay. Result, let's say, double, okay. In the end we have to return the double only, right here. So here double, okay. And this is nothing but my dp is equal to new hash map, all right. This is done, okay. So this code is done, this part code is done, okay. Now there is very simple a method, okay, how we are going to calculate this dp, okay. So inside this everything is done, all right. So now here what you need to do, let's write this private double, okay, double, and here calculate dp, and what I'm passing here, I'm passing A and B, okay. So here I'm just going to write int A, here I'm going to write B, and here I'm just going to pass this. Okay, just copy this, paste it here. Okay, this is done. All right, so now inside this base cases. Okay, base cases. So base cases are there, like if your a value becomes less than equal to 0. Okay, and b value becomes less than equal to 0. Okay, so in that case you have to simply return what? 0.5. Okay, 0.5. So that is, you can say both empty at same time. Okay, and here one more base condition, that if your a becomes less than equal to 0, right, then simply return from here. Okay, return 1.0. That's it. Okay, so here you can say a empty first. Okay, and here if b becomes less than equal to 0, then also don't need to check further. Okay, just simply return 0.0 from here. Okay, so you can say be empty first. Okay, this is done. So now here we have to check the memo. Okay, so that is the purpose of memo. Okay, so in memo what I'm going to do here, I'm going to check if my dp contains the key a. Okay, contains key. Okay, and here I will say a. Okay, contains key a. Okay, if my memo contains dp contains key a, and if for that a, if we have b also. Okay, so dp dot get b. Okay, for that particular a, get the value of b. Okay, dp dot get a. Okay, dp dot get a is going to give me the values. Okay, that a has. Dp dot get a is going to give me this. Okay, so I'm going to check if in this I have b value. Okay, so here I'm just going to write, and then dp dot get a dot contains. Okay, dot contains key b. Okay, so if I have both a and b, okay, then definitely I have this result with me. Okay, if this value is there in my, okay, if this key, then key value. Okay, key to key value. Okay, so here this like this in a key, and for this key the values are like here. Okay, and for these values also we have key value pair. Okay, like this. All right, so from here I'm just going to return dp dot get a. Okay, for a I'm going to get the values. Okay, and once I get those, from there I'm just going to get the value for b also. Okay, the keys which are there for b. Okay, so dp dot get a, I'm going to get all this stuff. Okay, then dot get b, so here I'm just passing this value so that I get this value. Okay, like this. So this is for use of memo. Okay, so now here this is very simple. Okay, what we are doing, we are just doing recursive transitions. Okay, transitions. So each serving option is equally likely uh, probability 0.25, right? Okay, so here what I'm going to do, I'm going to get the result. Okay, double result is equal to, here just to pass this in a spelling mistake, right? Here it should be l, calculate dp. Okay, done. Okay, so here what is going to happen, so here inside this you have to pass calculate dp, and here first time from a we are subtracting 4, and right, and here b is going to remain same. Okay, and yes, right. Okay, and here I can say this is for serve 100 ml, serve 100 ml from a, 0 ml from b. Okay, that's what we are doing here. All right, okay, let me write it like this. Now if I just copy this part, okay, this is one thing, this, then this, then this, control z, here this, ignore this. Okay, so this, right, and here calculate DP. Okay, I have to do the addition here. Okay, here also I have to do the addition. Here I also have to do the addition. Okay, so here calculate DP, A minus you can say A minus 3 and B minus 1. Okay, so here that simply means second operation 75 ml from A and 25 ml from B. Okay, and this is A minus 2 and here B minus 2. That simply means 50 ml. Okay, 50 ml from A and here 50 ml from B. Okay, or this operation A minus 1 and B minus 3. Okay, so that simply means 25 ml from 25 ml from A and 75 ml from B. Okay, so here all this, right, and in the end divide it with 4.0. Okay, or you multiply it with 0.25, your choice. Okay, so this is how we are going to get this. Okay, so let me just format the code. So this is how we are going to calculate the result. Okay, I'm calling the DP again and again. Okay, so here this part I have solved now. So if I still don't return, okay, if still base case condition is not there, then again 4 probabilities are there. Okay, so I'm going to call this method again and again. Okay, this one. Okay, this is done. So here whatever the result I'm going to get, I have to store it in memo, right? I have to store in memo. Okay, so here I'm just going to write a tp dot compute if absent. Okay, so it is going to check if we have that particular key available with me or not. Okay, so a key is there or not. Okay, so a, right, so if a is there, then take that, otherwise just create for this particular key a, create the new hash map. Okay, so new hash map. Okay, this is done. Okay, then in this what we need to do, we need to put, okay, okay, so I created for a. Now in this a I have to create this. Okay, so I have to put this key and this value, right? So dot put, and but I'm going to put b, and here I'm going to put a result. Okay, this is done. All right, and from here, from this method, you have to simply return the result. Okay, that's it. Okay, so this is our code. Now let's run it and see if there are any code issues. We'll try to fix that. So yes, there is some issues here. Okay, so here if you see, divide with 4.0. Okay, okay, this is ending here. Okay, this is ending here. We need one more. Okay, we need one more here, and we need one for 1 second here for this one. Here I am writing it like this: calculate dp. Okay, then here don't write now, this not needed. Now here, now it looks good. Okay, now let me just format the code. Now it looks good. Okay, this and this. Okay, now let's run it and let's see. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? Our solution is accepted, right? Okay, now here few more findings. Okay, so this is our code, complete code. All right, so now here if I create few more test cases, let's say for 50. Okay, ignore this 50, for let's say 500. Here let's say 1000. Okay, here bigger. Okay, here let's say 4000. Here let's say 4200. Okay, here let's say 4400. Okay, here let's say 4800. Let's say some bigger values, right? 5000. Now let's say much bigger values here also. Okay, 8000, 8000. Okay, that's it. Okay, so let's take it 80,000. Okay, let's take it as 5,000. Okay, and we have 4800. Okay, now let me run it. Let's see. So see here, for 500 output is 0.91. okay, now I am taking bigger values here, 1000, so 9.7, 9.1, 9.7, okay, increasing with n value. 4000 is 9.999, okay, 0.999, okay, for 4000. For this one, 99998, okay, here see, 44400, we are getting 9999, 0.9999, okay. Now here for 4800, okay, we are getting around 1, okay. Now here for all the bigger value, if you see, notice we are getting 1 always, right? Okay, right, for all the bigger value. So I can do one thing now. Here I can more simplify this code, okay. So this is good, actually this code is also good, okay, no issues with this, okay. But here, if you want to apply few shortcuts, okay, if you want to do some shortcuts, so here you can say that initially, if the n value, let's say if it becomes greater than 5000, with 4800 also I was getting a 1 only, so let's say I give 4800, okay, you can give any value, okay, starting from which we get 1.0, okay. So if my n value becomes greater than 4800, let's say, so I'm going to simply return 1.0, that's it, okay, that's it. Here I'm calculating the m value, right? And here let's not use this, okay, let's not use this memoization, okay. Here we have already solved this knife and becomes this one, okay, we are simply done this, okay. Here we are just going to calculate the dp, okay, for this and here let's say instead of dp now, let's say I am passing memo, okay. Okay, you can say memo, right? So here for this memo you can do one thing, you can create double, okay, here 2d array memo, all right. So here new double, and here m+1, and here m+1, okay. So for this we are storing the values, right? So here you are creating this memo, okay, and here you are calling this dp, okay, and here in this calculate dp you are passing ab, and here you are just going to pass double memo, okay. I'm not going to use HashMap now, all right, because I have already reduced this problem very much, okay. So here base conditions, okay, if a is less than equal to b, then return this, okay. And here okay, instead of this, what you are going to do here, this is also going to remain same. Here you have to just update it as a, let's say memo, okay. In the memo you are going to store, okay, in this memo 2d, okay, a and b value. So this I'm going to delete. So memo of ab is equal to this divided by 4.0, and from here you are just going to return what you are going to return, memo of ab, okay, that's it. So if I run it this now, let's see if we are able to pass both the test cases or not. So there is some issue, so let's fix that. Here semicolon is missing, add this, okay. Now let's see, here a few more changes are required actually. One second, let it run. So here dp now, here I need to change it to memo, okay. So here control plus find dp, okay, it will actually change everything, all right. So here what we need memo, okay, we need memo here, we need memo here, okay. Now let's run it. So we are getting time limit exceed error now for n is equal to 1000, n is equal to 1000, also we are getting time limit exceed error. Let's see, I am using memo now, okay. So here if I have already calculated the value of memo a and b now, so this line extra we have to add now. If memo a and b, okay, if we already know the value of this, okay, so that simply means that if this value is not equal to null, okay, that simply means that we have populated some this value here, okay. So in that case, from here, that is why we are using the memo now, we forgot to implement this, okay. Then we have to return memo a and b, okay, this, okay, this is done, right? Simple. So now let's run it. Now you will see. So see, for 500 also, 1000 also, we are getting the perfect result. 4000 also we are getting the perfect result, and for all others like 4800 or after 4800 or whatever values, I'm simply returning 1.0 in the starting itself, okay. So now if you see here, in the submissions this time. Okay, we were here. Okay, now if I submit this code, this is very simple code. Okay, so now you see we are here. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.